About simplifying complex numbers. So this first one right here, it says I times the square root of 18 plus the square root of negative 8. I'm going to zoom in here. So what you can do for this, what you kind of have to do for this, is first thing we're going to do is we're going to simplify this radical here. So it's going to be I times, in the perfect square to pull out of there is 9. Plus, okay, and then I'm going to do the same thing here. I'm going to factor this square root of 8. I'm going to take out the negative 1 first, and then I'm going to have the perfect square of 4 in there times the square root of 2. So we have something like this. All right, from here, this is going to simplify to a 3. So it's going to be 3 root 2 times I plus, well, this thing right here is equal to I. So I'm just going to put an I there. This breaks down to 2, so it's going to be 2 times root 2. So you end up with something like that. Okay, and the last step would be, because it's both of these terms have an I factor for it, so you can combine like terms here. So it's 3 root 2 I plus 2 root 2 I. So that would just be 5 root 2 I. Highlight that real quick. All right, for this next one, I'm going to do the same thing with just factoring the radical. So it's going to be I times the square root of, I'm going to pull out the perfect square of a 9 in there, and then times root 2 times, okay, I'm going to factor out the square root of negative 1, and then I'm going to factor out the square root of 8. All right, this becomes 3. So we have 3 times I times root 2 times I. Now the square root of 8, you can pull out a square root of 4 as the perfect square. It'd be square root of 4 times square root of 2. That square root of 4 goes to 2. And then we also have an I times an I here. So what we're going to do is combine everything here. So the 3, I'll try to color code this to make it a little bit easier to see. So the 3 times the 2 here is going to be the 6. Okay, this square root of 2 times this square root of 2 here is going to be 2. Root 2 times root 2 is 2. Okay, the only thing that's not highlighted, that's left that's not highlighted, is these i's here. Well, I squared is negative 1. So you end up with 6 times 2 times negative 1. So your final answer is negative 12. All right, for this next one, the first thing I'm going to do is factor out that square root of negative 1 on the bottom. Okay. The square root of negative 1 is I, so it's going to be 5 over I times root 5. Now, for whatever reason, you are not allowed to have an I in the denominator. So in order to get this to the numerator, to move the I, essentially what we're going to be doing is multiplying the top and the bottom by I. And while we're there, we can't have radicals in the denominator as well. So I'm actually going to multiply by the square root of 5 times I. Okay, so multiplying the top and the bottom by I root 5. Okay, now why this gets rid of the I, I'll show you right now. You have to multiply across here, so it'd be 10 times root 5 I divided by, well, root 5 times root 5 is 5, and then I times I is I squared. So you end up with something like that. Well, I squared is negative 1. So now what you can do is simplify this further. 10 over 5 is 2 over 1. So now you multiply across, you end up with 2 root 5 I divided by negative 1. So essentially your answer would be negative 2 root 5 times I. All right, this next one, we have 3 plus the square root of negative 5 quantity squared. So I'm going to set up the area model for this one. Now, instead of writing the square root of negative 5 here, though, I'm going to factor out that I and just write I root 5. And then I'm going to do the same thing over here. It is really important to understand that if it is a square root of a negative, you have to before you can do any operations to it, you have to transform it into that I term. Otherwise, the algebra won't work for it. All right, 3 times 3 is 9. This here is going to be 3I root 5. This is going to be also 3I root 5. And this is going to be 5 times I squared, which is really just going to be negative 5. Because I squared is negative 1. Okay, so it's going to be 9 plus 6I root 5. So I'm adding the 9, I'm adding these two up here to get the 6I root 5. And then I'm adding 5I squared, which is really just negative 5. So I'm going to put a negative 5 in there. Your final answer should be 4 plus 6I root 5. All right, in this last problem, again, the rule is you can't have I in the denominator, so what we're going to do, instead of multiplying it by I, you have to actually multiply it by a specific, special factor, and that factor is called the conjugate. So if you notice this is 7 minus 2I, the conjugate of that would be 7 plus 2I. So essentially either the subtraction or the addition just switch. So since that one's already a minus here, I have to do a plus over here. These are conjugates, and when you multiply conjugates, a special thing happens, and it'll make sense once we go through the problem of why this conjugate is so important. Okay. So from here, I'm going to multiply across, and you end up with 35 plus 10I on the top. Okay, in the bottom, we have 7 minus 2I. So what I'm going to do is actually set up the area model for that. And 7 plus 2I. So set up our area model really quick. Okay, and then we're going to fill this in. So we got 49 here. We have negative 14I here. Here we have 14I, which these will cancel. That always happens with conjugates. Those middle terms cancel. And finally, we have negative 4I squared. Okay, so from here it's going to be 49, this and this cancel, minus 4 times I squared, which is negative 1. So your final answer for this one is going to be 53. So you can just put a 53 on the bottom here. Okay, then you can see, is there anything that factors that out? Is there anything that would simplify here? And there isn't, so that is the final answer. So that's a video on simplifying complex numbers. Key takeaways: whenever you're doing any operations with complex numbers, make sure you factor out the I first. Simplify as much as possible first. It just makes it a lot easier. The next thing is you cannot have any square roots on the bottom. And since I is technically the square root of negative 1, you can't have any i's on the bottom. And by the bottom, I mean you cannot have an I or a square root in the denominator for any of these. So if you ever see an I or a square root on the denominator, make sure you know that you're either going to have to use conjugates. If it's a binomial, if it's a monomial, you'll just have to multiply it by that I on the bottom. You know, when in doubt, when you're multiplying binomials, make sure you just set up that area model. It helps keep track of all your work. And yeah, so that's basically it. If you have any questions about anything in this video, let me know.